Yes, hello there. Himanshu Pareek, this side, physics faculty at askIITians. So, welcome to another lecture of motion in one dimension. In the previous lecture, you guys have learnt about the speed, velocity, acceleration. Acceleration, I guess you haven't done it the previous lecture, but at least you have got idea about the distance. You have got the idea about displacement and such terms. Now, in this particular session, I am going to talk about acceleration and velocities. All right. So, first of all, I'm going to say that before you are coming for this lecture, I hope you guys have done the lecture number 2 of basic maths. Lecture number 2 of basic maths was completely based on differentiation and vectors, right? So at least that differentiation part we will need. All right. So if you don't know how to do differentiation of functions, I would say that you should stop here and you should go for the lecture number 2 first, which we have available. You watch that lecture and then you come back here. So basically, this particular session, we are going to cover these many topics: instantaneous velocity, instantaneous acceleration, and average acceleration. Now, students who have watched the differentiation topic, they would be able to relate it. That why I am saying that differentiation we need to know. Because when you calculate average velocity, guys, I'm starting with the chapter directly, this topic directly now, right? Because it is too much mathematical, but we need to understand their meaning, that physics we need to apply here. Okay. That mathematics which we have learned, we will be using that mathematics in this particular session. All right. So topics of this question would be directly coming in the grade 11 also, right? Of this particular lecture, you will be able to apply the same concepts in the grade 11 as well, right? So better if you learn here, it would be beneficial for you. So now I'm starting with the average velocity. First of all, let us just recall what we have done in the average velocity. Average velocity was total displacement upon total time. Total time you have taken. Delta means the large change, right? I have used these terminologies in the previous chapter. Delta means the large change. So total displacement. Displacement means change in position. Delta x over delta t. So delta x is a displacement, the change in position. Delta t is the time taken to change the position. And when you take the ratio, that's what we call the average velocity. Similarly, if somebody wants to define average acceleration, all right, so we will be doing it the same way. Delta of what? Velocity divided by delta of time. We will do it later on, but you should have some little bit idea about it. Now, instantaneous velocity. So what is instantaneous velocity? Velocity at a particular instant. At a particular instant. If you're driving a bike and if somebody asks you that at what speed you are driving, then you would definitely give the answer that I'm driving at 30 kilometers per hour. So how do you give this answer? Because you look at the speedometer of the car or speedometer of the bike, and then you give the answer. So the maths which we have learned, or the way we have been doing the average velocity questions, can we apply that here? Let us try to use it. Average velocity, we used to say that total displacement upon total time, which is basically change in position upon total time taken to change the position. I am talking about a particular instant. At a particular instant. When we talk about a particular instant, you do not have any interval. How you can find out the change? Yes or no? When you talk about a particular instant, let's say somebody says, find out the velocity at t equal to 2 seconds. How to do that? We do not have any change there. So if we don't have any change there, how to find out the velocity at a particular instant? Because we know to calculate average velocities for the large intervals, right? Suppose 10 seconds of interval displacement is change in position is 50 meters, like that. We were doing it in the last class. But how to deal with such questions when you are covering, when you're solving, finding the velocity at a particular instant? So for that, what we need to do, we need to find out the values, right, of differentiations. Why I'm saying this? So for that, you should recall the lecture number 2 of basic maths. Suppose, okay, we don't know to find out the velocity at a particular instant, that's okay. But what do we know is to find out the change for a very small interval, change of a quantity in a very small interval. Let us just recall. Suppose y versus x graph is given, and if y versus x graph is going this way, now how y is changing with respect to x, at what rate it will change, how fast it will change, how slow it will change, that is given by the slope of the curve, and which is also equal to dy by dx. If you're getting scared at this moment, again I'm telling you, go to the lecture number 2 of basic maths. You will understand these things, don't worry. Right, the last lecture of basic maths. How fast or how slow y is changing with respect to x, this idea you get from the dy by dx. So suppose this is the change in y, dy, small change, and this is the small change dx. And then you find out the slope of the straight line, the tangent to the curve. So actually what I'm saying, that when you want to find out the instantaneous terms, what you should do, you should take a very small interval, a very, very small interval, infinitesimally small interval. That a small interval you take, in that small interval you can say that yes, it is instantaneous. That interval is of a very small size, 0.00000000001 second. If this much small interval you take, obviously you can say it's an instantaneous thing. Got my point? So that's how we say that, that's how we find out the instantaneous velocities in physics. All right. So always remember that whenever we'll be finding out the instantaneous terms in physics, the differentiation will come into the picture. The small change we will see with respect to another small change. All right. Now let us begin with the instantaneous velocity first of all. So how do we say the instantaneous velocity? Velocity at a particular instant. So right now you can see that this is a speedometer of a motorbike. All right. So this reading you can see, that's a speed, 233 kilometers per hour. That's too much. Okay. So at this speed, this particular motorbike is going. Now you guys would see one, if you want to find out the instantaneous velocity, what you should do. So velocity at a particular instant is given by, let me represent it in a better way for you guys, the way you will be learning in the grade 11. We can do that. We can do that here because now we know the differentiation. So instantaneous velocity is equal to, can we say that instantaneous velocity is nothing, but it is an average velocity, but in a very small interval. See, that's how we find out the average velocity. But right now we are talking about when delta t becomes very, 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 very small. When delta t becomes very, very small, then we get the instantaneous velocity. And this can be said now, if it is very, very small, dx by dt. Because delta is used for the large change and small d is used for the small change. Always remember. So now we are talking about a very, very small interval. So dx by dt. Got my point? So let us see one thing. And do you remember? Dx by dt, what it will give you? Slope of the curve. Dy by dx gives slope of the y versus x curve. Dy by dx gives the slope of y versus x curve. So dx by dt will give the slope of x versus t curve. It's a similar thing. See, dy by dx will give you slope of y versus x graph. So dx by dt will give you what? Slope of position versus time graph. So basically, let's say the position versus time graph is shown by this. Got my point? Now, You can see if you take a very small time interval, though here I have taken a little bit large just to visualize it, otherwise it's a very small interval. So this is the dx, okay, and this is the dt. So this is dx and this is dt. This vertical length is dx. So now the tangent to this curve, if you draw, then slope of this tangent would be the instantaneous velocity. I think I am telling you a little bit higher stuff, but you should be able to relate it if you have seen the last lecture of basic maths. What is the meaning of dx by dt? For a very small interval, we represented by dx by dt. Got my point? Okay, that is what the dx by dt means, and the instantaneous velocity is. So again, we can see here, this is the curve. When you take the large interval, it is become delta x, and when you take small interval, it becomes dx. So large interval means total displacement upon total time. But when you take the small interval, we take a very small interval size of dt, very, very infinitesimally small interval, right? And that would be happening when delta t is becoming 0. And that would give you what? Instantaneous velocity. So do not get scared from it. Instantaneous velocity is nothing but just you're finding average velocity only, but in a very, very small size interval, right? Total displacement upon total time. How I'm writing total displacement? By change in position. That's it. That's what they have mentioned here. Slope of equal to instantaneous velocity at point P. Okay, let us solve this question. Let me recall, how do we use to differentiate the functions? So we have used this formula, d by dx of x power n. The formula is n x power n minus 1. If somebody has given you this kind of expression, some constant x power n, then simply take constant out of the differentiation. Simply take it. And now you know how to differentiate x power n. It is nothing but n x power n minus 1. Differentiation of a constant number is 0. Right? So these things we know from our differentiation class. Now, let us solve this question. Calculate the instantaneous velocity of a particle traveling along a straight line at time t equal to 3 seconds, whose position is changing by this relation. Right? Along a straight line with the function x is equal to 5t square plus 2t plus 3. Means basically this question is saying, this particular topic is saying that if x value changes with respect to time, right? So they are asking you now, what is the velocity at a particular instant? At a particular instant, they're asking you the velocity. So suppose, let us start here. Let us make one table. At t equal to 0, what is the position of particle? Let us do general analysis first of all. Answer we can find out within a second. Let us do a little bit analysis. So x is equal to 0, t equal to 0. What is the location? 3. Just put the number here. In this expression, put t equal to 0. You will get 3. Now put t equal to 1. You will get 5 plus 2 plus 3, which is 10. Now you put x is equal to t is equal to 2 seconds. So t is equal to 2 seconds. How we will get 5 multiplied 2 square? 2 multiplied 2 plus 3. 4 5s are 20. 4 4s are 2 2s are 4 plus 3. 24 plus 3, 27. Let's find out that 3 equal to 3 seconds also. Last one. 5 multiplied 3 square. I'm just putting the value of t here. That is giving me the x location. 5 multiplied 3 squared, 2 multiplied 3 plus 3. 3 square 9 plus 5, 45 plus 6 plus 3, 53. So that's the value of x, means the location. X is equal to t equal to 0, particle is at x is equal to 3. In this interval, particle has covered how much distance? See, just take the difference of these two. 10 minus 3, 7. Particle has traveled a total of 7 meter distance. In this interval, 27 minus 10, 17 meter. In this interval, 26 meter. So actually, if you see in equal intervals of time, equal interval means 1 second interval, 1 second interval, 1 second interval. In equal intervals of time, particle is not covering equal distances, which is a non-uniform motion. Means the particle velocity is changing with respect to time. You should be able to analyze like this. So now if the position is given by this expression, now we know that differentiation of position with respect to time, differentiation of position with respect to time gives you what? Instantaneous velocity. Let us find it out. Whatever answer I'll get, I'll put t equal to 3 there. So let us find out the instantaneous velocity. So what I'll do for that, have a look here. Instantaneous velocity. So d by dt of 5t square plus 2t plus 3. Got my point? D by dt of entire position vector. Entire position thing you write here. Now, so d by dt of, I can do separate differentiation. 5t square plus d by dt of, second term was 2t. Third term was 3. Let us just have a look. Yeah, 3. Now, if you know differentiation, then you should pause here and try to do the differentiation of this thing. I'm doing it here on the board. Otherwise, you should do in your notebook yourself. So in this lecture, there's nothing to teach from my side. Everything is covered in the basic maths lecture. Right. What is the differentiation of this? 0. What about the differentiation of this? Take 5 constant, d by dt of t square. Take 2 constant, d by dt of t plus 0. What is the differentiation of t square? So apply the formula. X power n differentiation is n x power n minus 1. So here n value is 2. So 2, in place of x we have t here, 2 t power 2 minus 1. N x power n minus 1. So in place of x put t, in place of n put 2. Similarly, here t power 1. So n value is 1. So 1 t power 1 minus 1. Solve it. 5 2t plus 2, because t power 1 minus 1 is 0. 0, t power 0 is 1. Any number power 0 is 1. Why it is 1? Any number power 0? You can write it like this. T power 1, t power minus 1, t power 1 upon t power 1. T power 1, t power 1 would cancel out 1. So that's why any number power 1 is always 0, is always 1. So this will become 2. Now this is the instantaneous velocity. So velocity is changing with respect to time like this. Okay. Now you put t equal to 3 seconds here. So what will be the instantaneous velocity? 2 multiplied 3. Just put t equal to 3. That's it. You'll get the instantaneous velocity. 2 3s are 6 plus 2 8. 40 meters per second. Units per meter per second, right? Yeah, meters per second. Okay. That's it. So basically, Just learn the differentiation, and then you should, before that, you should have a feel of differentiation. What does it represent? Why it is representing a slope? I have explained it with a slope of a straight line. If you were there in this lecture, that lecture, you must have understood it. And then you just apply it in different cases. That dy by dx, that y can be anything, that x can be anything. Now I'll talk about the average acceleration. So when I'll talk about the average acceleration, then how did I define average velocity related with the previous concept? Average velocity, I said, total displacement upon total time. Displacement means what? Final minus initial, right? Destination minus starting point. So change in position, x2 minus x1 upon total time. Similarly, how do we define average acceleration? How we will define the average acceleration? Acceleration represented by the symbol A, average, AVG, short form I'm writing. So delta V, the change in velocity, divided by delta T. It is also a vector quantity. Velocity is a vector quantity. We have seen it, right? It requires a direction for the representation. Similarly, acceleration is also a vector quantity. It will require a direction for its representation. So delta V upon delta T is what? The average acceleration. So change in velocity upon time. What is this red color thing? This arrow is representing. This arrow is representing the vector sign. Okay, that it is showing that this thing is a vector quantity. Now this is the average acceleration. So basically, or simply, you can write it as final velocity minus initial velocity divided by total time taken to change the velocity. Simply in a language form, you can write it as change in velocity divided by time taken to change the velocity. Got my point? Now, let us use this equation first. See, it's very simple now once you understand the differentiation. Again, you can see here instantaneous acceleration. Acceleration at a particular instant. At a particular instant. Acceleration at a particular instant is known as what? Instantaneous acceleration. So if somebody gives you velocity versus time graph, let's say the velocity versus time graph is given like this. Okay. Let's say this is velocity time t1 and velocity at this instant is v1. Let's say this instant is t2 and velocity at this instant is v2. Right. So what is a change in velocity, guys, from t1 to t2? Change in velocity. v2 minus v1. Final is v2, initial is v1. How much time it has taken? t2 minus t1. t1 and t2 are instants. So what is the average acceleration? If I simply want to write down the average acceleration, it would be how much? It would be total change in velocity divided by total time taken to change the velocity. v2 minus v1 upon t2 minus t1. All right. So now what is the instantaneous? So instantaneous means a very small. Achha, by the way, I can write it like this also, delta v by delta t. Because change means delta, right? It's a large change. Suppose if somebody is talking about a very, very small change, very, very small change, infinitely small, dt, this change on y-axis, dv, what do you will write here? Instantaneous acceleration. That when this delta t in the limiting case, this LIM is representing the limit. Limit. You'll be learning this in the grade 11. Don't worry about it. Limit means the limiting case, tending to. When delta t is tending to 0, approaching to 0, very, very small interval. Then this small change will be represented by dv, small change in velocity in the small time interval. That is what we call the instantaneous acceleration, right? So dv by dt is what? Instantaneous acceleration. Now always remember that dy by dx we have learned, and we said that the dy by dx is representing the slope of y versus x graph. Similarly, the slope of velocity time graph, because here in place of y you have what? Velocity. In place of x you have time. So velocity time graph slope will represent what? Velocity time graph slope will give you acceleration. Very, very important point. I'll rewrite them just a second here. Yes, we can write down here. Slope of position velocity time graph. Slope means dy by dx. So here it is velocity on the y-axis. So dv by dt will give you acceleration. Point number 1. Point number 2. Slope of position time graph dx by dt will give you velocity, instantaneous velocity. Always remember, it will give you what? The instantaneous velocity. So that's how we should remember it. That slope of velocity time graph, instantaneous acceleration, right? Slope of position time graph, slope of position time graph, velocity, instantaneous velocity. Got my point? Now let's say the instantaneous acceleration. Let's talk about how do we find out instantaneous acceleration. So here, yeah. So instantaneous acceleration, very simple. Just take the differentiation of velocity. If somebody says I won't give you velocity, like in this question, determine the instantaneous acceleration for the object movement at time of 3 seconds. At a time second, we have to find out what instantaneous acceleration at t equal to 3 seconds. It's a very similar question. So what I'll do, I need to know the value of velocity if I want to find out the acceleration. So what you should do, first you should find out the velocity, right? So how? This is the position. That's the position changing with respect to time, right? Position changing with respect to time. 5t cube plus 7t square and like that. Okay. So once we know that position is changing according to this equation, 5t cube plus 7t square plus 15t plus 62. Can we find out the velocity? Yes, dx by dt, which will give you the velocity, right? So do the velocity in your notebook, how do the differentiation here, and then you redifferentiate it, means 2 times differentiation of position. 1 time differentiation of position, velocity. 1 more time differentiation of position, acceleration. 1 time differentiation of position vector, position expression, velocity. Again differentiate it, acceleration. Wait, we'll do it here now. So dx by dt, we can write it as d by dt of 5t cube, d by dt of 7t square, then d by dt of 15t, and in the end d by dt of 62. You can see that all these terms will become zero. This term will become zero. Constant term differentiation is zero. Got my point? Okay. Now let me write here. Okay. So velocity is equal to what? 5t cube. 5 will be constant. Take it out of the differentiation. T cube differentiation will be 3t square. How did I do this? T cube differentiation. 5 will be constant. 3, that x power n formula, n x power n minus 1. T 3 minus 1. Now other terms I will write directly now, because you should be ready now after doing the practice also. So 7 d by dt of t square, 14t. 2t will come, multiply with 7. Differentiation of 15t. Take 15 constant, d by dt of t is 1. So ultimately you are getting 15t square plus 14t plus 15. Now you look at this expression. Once you differentiate the velocity, you get what? Acceleration. So d by dt of 15t square plus 14t plus 15. So when you do the differentiation, take 15 common for the first time. D by dt of t square, 15 will come out of the differentiation. D by dt of t squared, 2t power 2 minus 1. So into 2t plus d by dt of 14t. 14, because d by dt of t is 1 only. Because 1 multiplied t power 1 minus 1, t power 0 is 1. Plus d by dt of 15, 0. So what is the answer? 30t plus 14. So that's the dv by dt, which can also be called as instantaneous acceleration. Now you put t equal to 3 seconds. You wanted to find out the instantaneous acceleration at t equal to 3 seconds. So let me put it. 30 multiplied 3 plus 14. 33 is a 90. 90 plus 14 is how much? 90 plus 14 is 104 meters per second square. That's the unit of acceleration. If I forgot to tell you the unit of acceleration. So just see velocity upon time. Velocity unit is meter per second. Time is second. So this will come in the denominator. So meters per second square. If it is kilometer, then kilometer per hour square, or accordingly, the scaling. Okay. So that's the point here, that 33 is a 90 plus 4, 104 meter per second square. So you can recheck it if I have made any calculation mistake, right? So pardon me for that, right? So that's how we find out the acceleration. You should always, one mistake every student does when they learn these type of question for the first time, what they do is actually they do not write down the they just differentiate the t equal to 3 seconds, and they the position, and then they find out the velocity, and ultimately they just put t equal to 3 seconds here. That would give you the wrong answer. First you should find out the final expression of acceleration, and then you should put the tally of time, like as I have done here. First I calculated the general expression for acceleration, then I differentiated. Now I'm giving you one homework. Homework is, okay, let us do it here only, right? Because 80% part we have already done in the previous question. Suppose for this question, if somebody asks you to find out acceleration at t equal to 3 seconds, acceleration at t equal to 3 seconds. So velocity we have already got. Where is the velocity? Next page. This is the velocity, right? Okay, just differentiate it one more time, because differentiation of velocity gives you what? Acceleration. So 10t, this will give you what? 10t plus 10. So differentiation of this will give you, first term differentiation, 10 constant, so outside, 10 dt by dt is 1. 10 dt by dt is 1. So 10 plus second term 0. Answer is 10. Means what? Means that dt by dt, this acceleration here will be 10 meters per second square. Is it depending upon time? No. It's not depending upon time. If it is not depending upon time, then acceleration would be constant, whether you find out at t equal to 1 second, 2 second, 3 second, or 4 second. Got my point? Now, listen one more point. This thing I'm giving you as a homework. You should think about it. Spend some time to think about it. If highest order in any expression, let me write here. Suppose I give you some expression, right? And highest power of time is 2. No power should be negative. So like it should not be like 3t power minus 1. That is not allowed. If highest power is 2, then the differentiation is the acceleration would be a constant with respect to time. You would see this thing in many books that if position is proportional to time square, then acceleration is constant. Always. Very true. If position is proportional to time square, then acceleration will be a constant. Think about it. Position can be 10t square, 5t square, 8t square, 9t square. It can be anything. Some other terms can also be there. 3t plus 4t plus 5t, like that. In such cases, acceleration would be always constant. Think about it. Why? I am taking the last question for the day. Right. A racehorse coming out of the gate accelerates from rest. So initial velocity 0. I always write down the conditions given. To a velocity of 15 meter per second. Final velocity is 15 meter per second. Due west in 1.8 second. Time taken to do this. 1.8 second. What is the average acceleration? Very simple. Average acceleration means total change in velocity divided by total time to change the velocity. Final is 15, initial is 0 divided by 1.8. So answer is 15 by 1.8. Which we can simplify here. 15 by 18 multiplied 10. So 3 5s are 3 6s are. All right. So here we can say 5 10s is 50 divided by 6. So 25 by 3. And unit meters per second square. That's how we find out the average acceleration. But if they give you the position time relation, velocity time relation, then also we know how to find it out. So what did we do today? We learned the concept of instantaneous velocity, instantaneous acceleration, and average acceleration. So ultimately, the instantaneous velocity means the change in position with respect to time for a very, very small interval. That's a trick. And how to learn this, how to do this dx by dt, there's very small differentiation, a very small change, how to deal with that. So that for that we have a new mathematics which is called the differentiation. Then acceleration, dv by dt. All right, so that's how we always resolve that's how we always find out the value of velocity and acceleration. I hope you have understood this lecture. If you have any doubt, then please put it on batch discussion forum, BDF. All right. And please keep solving the questions, because practice only would make you perfect here. Right. So if you don't know differentiation, go to the lecture number 2 again, the last lecture of basic maths. This lecture you would find very, very simple, because this is nothing but simply the application of that differentiation part. We have just replaced y and x here. Got my point? So that's all from my side. Thank you so much, guys. All right. Bye-bye.